Good morning, my dear friends, ladies and gentlemen. I am pleased to welcome you all to the 139th weekly webinar organized by AABN. In this virtual room, I recognize some familiar names of participants from diverse groups. You have all worked tirelessly on the agenda for this webinar series. I am sure at AABN we are also reaching out to many new friends, practitioners, technologists, innovators, and business professionals. A very warm welcome to you all. We all understand the importance of science, technology, and innovation in our day-to-day lives and the ways in which they are transforming the world. Equally important is our collaboration and networking in this great effort. These webinar series are designed to help aspiring entrepreneurs visualize the possibilities, identify resources to support their vision, and understand the logistics of starting a business. This Sunday too, you would be delighted to know that we have an illustrious speaker, Mr. Ramasamy Devaraju, and he will share his thoughts on change and challenges, disruptions in automotive industries. The global automotive industry is on the verge of disruption. Digitalization, increasing automation, and new business models have revolutionized other industries, and the automotive industry will be no exception to such a revolution. The Indian automotive industry has started to experience the effects of the global disruption. How prepared are automotive stakeholders for this disruption? And how can they ride the change to expand their newer areas? Automotive retail is changing with unprecedented speed and magnitude, driven by shifting customer expectations, new mobility offerings, and technological disruptions such as digitalization, vehicle connectivity, and electrification. The pandemic has further accelerated the transformation, encouraging consumers to adopt a digitally enabled car buying and buying and online sales models. On the business side, COVID-19 has increased the cost consciousness of OEMs and dealers who are now making decisions about further outlet consolidation, leaner retail formats, direct customer accounts, and alternative sales models. This webinar outlines the importance and imminence of the disruption, the drivers of electric vehicle penetration, and the implication for all stakeholders, especially auto component manufacturers. Acknowledging the upcoming disruption and reinventing the business accordingly is the key to managing the changes that lie ahead. I have the pleasant duty of welcoming and introducing our guest speaker for today, Mr. Ramasamy Devaraju, automotive retail consultant, to this interactive business networking session. Devaraju, an automotive engineer, graduated from MIT Anna University with a management degree from Kamaraj University, Madurai. He has over 35 years of core automotive management experience in both sales and after-sales auto industry. He has had an illustrious career working with premium automotive brands both in India and overseas. Key highlights of his career were his employment in Malaysia for 17 years, associated with sales and after-sales for Mercedes brand. He retired in 2021 as the group CEO of a multi-brand distributor, overseeing brands like Ferrari, Maserati, Mercedes-Benz, Kia, Peugeot, and Ducati. He is currently relocated back in Bangalore, India, and continues to be associated with the automotive industry as an automotive retail consultant, providing his expertise to companies both in India and overseas. With a guest speaker with distinguished experience, I'm not going to extend my speech because I would like him to take over as we discuss different emerging views and innovations in the industry, the opportunities and challenges. I believe today is going to be a day of learning for each one of us. Hope you have an engaging day that is beneficial for the future of your careers and the industry at large. Thank you, and over to you, Mr. Devaraju.
Thank you, Gobi. Thank you, really. And it's a real great opportunity to join the association to have some kind of a discussion what is taking place in the automotive industry. And thanks to all your members to giving me an opportunity to share my views in this forum. Basically, can you all hear me?
Yes.
Okay, thank you. Basically, I'm going to talk in this 1 hour presentation. What is really the changes are taking place in the automotive industry? That is they called disruption in automotive industry. Okay? Everyone is aware. A lot of changes are taking place in the automotive industry, either through social media or other platform. Informations are flowing, so people are aware. Some changes are taking place. How the changes are going to impact? That's why very important for us. Okay. OEM is nothing but a manufacturer of all automotive cars. Okay, these people already they are aware of all these changes and they started working themselves and preparing themselves to face these challenges. But people like connected members, the rest of the connected members, maybe a retailer, automotive retailer, or a technical staff who is working in the auto related business, or even end customer who is all these people are connected in auto related business, but are they fully aware what is happening in the industry, the changes, and are we well informed and prepared? This is a big question mark. In this presentation, I am going to talk about the changes and what are the implications for related members. Transformation over the years. In the automotive industry, a lot of changes are taking place over the years. Ever since, okay, just like if you see up to 80, where I graduated in MIT 1985, during that time when I started entering into the industry, people were talking mainly in automotive engineering, mainly mechanical engineering was dominated. Almost 80 to 90% is the mechanical engineering in the automotive side. Only 10 to 15% in the electrical. Electrical also like battery, alternator, ignition system, lighting system, etc. Rest all the mechanical side. From there, now between 1980 to 2000, there is small changes were taking place, which is called electronics started coming into the automotive sector. Electronics started slowly replacing the electrical ignition system. In the electronics, they started coming transistor, diode, all those things started coming into automotive engineering, which was completely replacing the mechanical ignition system. Mechanical ignition system in the sense there was a contact breaker point and the timing, all those things. Those days, the customer need to take the car regularly within few thousand kilometers to check all this preventive maintenance and all. When the electronics started coming, then the duration of the service interval slightly increased because there is no wear and tear on the ignition system and all. Okay. Further, in between 2000 to 2015, people started talking about a hybrid car. All the while, up to 2000 or 2010, people were mainly talking about IC engine. We all know only IC engine is the heart of the car. From the IC engine, then they started slowly talking about hybrid. In hybrid model, there is IC engine. Of course, IC engine is there. Along with the IC engine, there is a battery also inside the car. But these two together is the technology combined to engine and battery together, the technology called hybrid technology. So this is the change that has taken place in the hardware side. At the same time, because of the internet development, software also started coming into automotive engineering, which is called telematics and connected cars. So in around 2000 to 2015, the changes are taking place, changes were taking place both in hardware and software. Hardware in the form of batteries coming into the automotive car, and software in the form of telematics and connected cars. So from there, now, from after 2015, again, a lot of changes is taking place. On the hardware side, the hybrid cars became a fully electric car. Okay, so the IC engine is completely moved away from the automotive engineering. There is no IC engine at all. So the battery is a big battery is dominating the position of the IC engine in the fully electric car. On the software side, telematics and connected together all started working together. That's called SDV, software defined vehicle. The automotive engineering software completely dominating the automotive engineering. So from there, with the software defined vehicle is all leading towards a fully automated car or self-driving autonomous car. So you all know people talking autonomous car, autonomous car. There are many manufacturers in a country like US and UK and other Germany and all. They are fully spending a lot of money on the infra R&D, how to develop autonomous car. So, but still autonomous car in the early stage, but almost, if you ask me my personal view, almost around 60 to 70% of the work completed for autonomous car, which I'm going to talk in the further slides on the technical side. So this is the changes taking place over the years in the automotive industry. Personally, if my experience when I started in 1985 as a management trainee in the Hindustan Motors, I started with the mechanical. Slowly, I moved along with the changes. I can see from the mechanical and the software technology today. So this is the complete transformation over the years in the automotive industry. What is the current trend? The current trend is taking place like electrification. Electrification is taking place in the automotive engineering. From there, telematics, connected cars, software-defined vehicle, fully autonomous car. These are the changes are taking place. So I put it into two part, hardware part and the software part. Hardware part is electrification, battery, and the changes in the body engineering. All those things are coming under hardware part. Software part is telematics, connected cars, and the fully autonomous car is mainly dominated by the software. With these all changes, what is the impact is taking place? Impact in the taking place both the technical as well as the financial side. On the technical side, both manufacturer and the dealers and the retail side, all those people really need to change the infrastructure to suit the high-tech new cars. All the while, when the mechanical car was there, so the infrastructure was tuned towards repairing the mechanical car or maintaining the mechanical car. But when the new high-tech cars are coming with software and all, that is not sufficient enough to manage these cars. So that's where both the manufacturer side as well as on the dealer side, they need to improve the infrastructure to manage these cars. On the manufacturer side, charging infrastructure and other things and all, they need to manage it. On the retail side and the dealer side, the existing workshop will not be sufficient to manage the high-end cars. That's where a lot of investment is required to invest on the dealership to maintain the high-end cars. At the same time, on the human development side, on the dealership as well as the manufacturer side, the existing the team of people, where particularly older generation, all are tuned towards a mechanical engineering and partly the transition side. But when the new technology is coming, IT, software related and all, we need to really have a new generation team so that they can able to pick up and manage it very well. This is where now the existing team, we need to impart a lot of skills to learn and to manage these changes. At the same time, we need to hire new generation of staffs so that the new generation of staffs, they can able to, I have some echo, I don't know others. Hello? Hello?
Yeah, it's clear, sir.
Yes, clear. Okay. I was having some echo. Sorry. Okay. On the HR side, these technicians, we need to hire a new technicians so that they are having some kind of a IQ plus software and IT knowledge and all. So with this kind of a combination of HR, we can able to manage it. So with this, all those things, infrastructure and technical know-how for the staff and all, there's money and time is involved. So a lot of investment is going to take place on the infrastructure and hiring a new staff. On the financial impact, now, this is another important point. With the infrastructure and investment is going both manufacturer side and the retail side, how the financial impact is taking place. I'll be touching the later part in the slide. On the financial side, a manufacturer, they are in a bit upper hand. They can able to manage it, the profitability, but still it is not an easy task. But in the retail side, it is further difficult to manage when the reduction in the return on investment and other things. So profitability is a big task. We will be covering later in these slides. Okay, now we'll go towards more technical and mainly in the hardware side. Okay, when the IC engine is there, what are the components are there in the IC engine? Just to have a knowledge, okay, there was engine components and cooling system, exhaust system. Exhaust system has got some kind of additional units, catalytic converter, O2 sensor and all, and fuel system. These all were there in the IC engine cars. At the same time, when the EV cars, what are the components are additionally is coming? You see, in the EV cars, okay, it's a battery. This is like a heart of the engine. Battery is a heart of the engine. In the IC engine is a heart, but in the EV cars, battery is a heart. And from there's electric motor, powertrain, thermo management. So in order to maintain the operating temperature, we need to manage the thermo management, inverter and power control unit, high voltage cables and the charging port. These are the additional the parts are coming in the EV car. Whatever the parts are available in the IC engine, this all is moved away. No more engine, no more cooling system, no more fuel system and all. Okay, when in IC engines time, there are 200 rotating parts in the drive system. At the same time, in EV cars, only 20 rotating parts. How the parts is reduced in EV. You know, in mechanical engineering in the IC engine time, when the fuel is ignited in the cylinder, the power is taking place on the piston. Piston started moving, connecting rod started moving. So from there, the crankshaft started moving, and the transmission, propeller shaft, and wheels. You see, once the ignition is taken place from the cylinder, in order to move the wheel, there are so many connected parts, either moving parts and rotating parts, which will reach the wheels. But in the EV cars, the moment the power is transferred from the battery, it is through inverter, it is going to the electric motor. Electric motor, up to that, there is only a power transfer. From the electric motor, the rotor is started rotating and rotating the wheel. So the rotating parts is from the motor to the wheel. So that's where the reduction of rotating members are taking place from 200 to 20. Because of these changes in the rotating parts or reduction in the rotating parts, efficiency of the IC engine and EV is a big difference. When in the IC engine, efficiency was only at 30%, like what I was mentioning. From the cylinder, the power is generated from the cylinder to transfer the power into wheel. There are so many components involved, the frictional loss and other losses and all. So that's where in automotive engineering, IC engine side, only 30% we can able to use efficiency. Whereas in EV, almost 80% we can able to use the efficiency because of less rotating parts. There is hardly any rotating parts. That's where we can able to gain full efficiency of 80% of efficiency in the EV cars. Now we will talk about more about EV car. Okay, on the EV car, what are the components are involved and the functions? Like I was mentioning, battery is the main component, like a heart in the EV car. Okay, the battery is made of lithium-ion battery. In the battery, electrical energy is stored in the DC form. Okay. When the battery is getting signal from the controller, when the driver is accelerating, the information goes to the controller. The controller is giving signal to the battery, and the DC energy will flow from the battery to inverter and eventually to the motor and the wheel. So this is battery is very important component in the EV car. If you take the value of the battery, almost 60% of the car value is coming from the battery value. This is so important, battery. Normally, if you see in automotive, the car side and all, warranty, manufacturer will give warranty 3 to 5 years. Those days it was less than 3 years. Now almost they are giving 3 years warranty. Some manufacturer, they are giving 5 years warranty, but that is for the car. Now, for the battery being so important, in order to instill confidence to the customer, the battery, their manufacturers are giving almost 10 years warranty or guarantee for the battery.
CCN choir music concert is on 29th October in the Coimbatore College Auditorium. It is a ticketed show. Rupees 250 and 500. So if interested, please collect the tickets from her.
Hello, there is some voice in between.
Maybe.
Can I continue? Hello?
Yes, sir.
Okay, sorry. There was some disturbance voice inside. Okay. Okay, that is on the power pack. Then the next component is inverter. You know, in the battery, the power is in the form of a DC, direct current. But in order to rotate the motor, we need AC current. So this is where the inverter is coming into the picture. So it is converting DC current into AC current and supplying to the traction motor. Motor is the one which is rotating the wheel. So inverter is playing an important role to convert a DC into AC. At the same time, when there is a braking is taking place in the car, so there is a regenerative energy is taking place. When the regenerative energy is taking place, this energy is, we are using the energy to charge the battery. But the regenerative energy is in the form of AC. So, but when we need to charge the battery, we need in the form of DC. So the same inverter is used to convert AC into DC. So inverter is playing a dual role to convert DC into AC in order to supply to the traction motor. But at the same time, when there is a braking and regenerative energy is taking place, it is also converting AC into DC, which in turn charges to the battery. Controller. Controller is a component which regulates the energy from the battery to inverters and eventually distributed to the electric motors. How the controller is getting an input? Controller get a main input from the pedal. When the driver is moving the pedal, so pedal setting determine the frequency variation or voltage variation that will enter into the motor. So based on the frequency variation and the voltage variation, that will give a signal and which will allow the battery to discharge according to the variation, the amount of current to go into the motor. That will determine the speed and torque of the car. Motor is getting power from the battery and converting electrical energy into mechanical energy. So the moment the power is coming to the motor. Motor has got, as everybody is aware, they got a two component, a stator and rotor. So the moment power is supplied to the stator and the rotor started rotating. So eventually the rotor is connected to the wheels and wheels started rotating. Transmission is a kind of a reducer. The moment rotor is rotating, then the power is transmitted to the vehicle, to the transmission. The another component is a main component is called a DC-DC converter. As we all aware, in the battery, there is high tension voltage is saved in the battery in the form of DC. But whereas in the car has got so many accessories like lighting system or infotainment system and other power window, etc., etc. So in order to operate, we need a low voltage power to operate these accessories. So that's where we need a step-down converter. This converter is reducing the high voltage to low voltage, which is supplying to all the accessories to operate. At the same time, there is an auxiliary battery is available. So in order to charge the auxiliary battery, we need a low voltage. So DC to DC converter is doing this job to charge auxiliary battery as well as all the accessories fitted in the car. Thermal system. When there is a lot of electrical, like a battery and electric motor, all these things are operating. It is power electronics and all. When all these items are operating, so heat is generated, but heat is not good. So in order to maintain the operating temperature, we need to have some kind of a cooling. This is where the thermal management system or temperature management system is coming into the picture. So this can be in the liquid cooling or natural cooling or forced cooling and all. So few technology they used to maintain the operating temperature of all the electrical components. Charge port. So this is the charge port is like where the customer used to charge the battery through this port in the car. So the charge port again, it can be AC charge or DC charge. AC is like now whenever we have some kind of a junction box, we can ask the manufacturer to fix it or dealer to fix it and all. At our house, we can charge through AC charging. But at the same time, you want to have a DC charging is also possible with additional infrastructure where they are doing it outside. Now, let us see what are the charge speeds. There are slow charge, so at the range of 3 kilowatt. In order to do the slow charge, it will take maybe based on the 3 kilowatt, 8 to 10 hours, you need like a overnight charge. In order to charge a full battery, you need to have an overnight charge. On the fast charge, so fast charge is more towards a DC charge and almost around 3 to 4 hours, we can able to charge the car. And the rapid charge is 30 to 60 minutes, which is having a 43 kilowatt. This also, but all these things today is still we need to do a lot of infrastructure to have all these chargings. But today's charging, slow charge and fast charges are taking place. But I understand Tata Power company is working with some other people and all. They are trying to work on the infrastructure on the fast charging and rapid charging. And for few other companies are working in India to develop all these charging stations. Let us see what type of electric vehicles. When it started, this were the hybrid, all started with the hybrid. In the hybrid electric vehicles, there is an IC engine, but there is no external charging. So this is there is a battery in the car, and the battery is charged by alternator and other source of internal charging system. At the same time, when there is a braking and regenerative system is charging the battery. So basically, there is IC engine, there is a battery, and all these charges on the battery is taking place internally. Then the second one is plug-in hybrid. This again, there is IC engine is available, but at the same time, there is a external charging also available. So in the external charging is charging with like a slow charger or fast charger. Their support is available and we can charge it. But at the same time, engine is also available. So mainly when this kind of a plug-in hybrid or hybrid vehicle, so it is a combination of working engine and battery power. Particularly when you are in a slow speed or idling, all kind of situation and all, battery energy is used to, to, to operate the system. The moment when you started increasing the speed and where you need additional torque and all, so both the engine, IC engine power as well as the battery power is added together. So that's where working in the hybrid or plug-in hybrid vehicles. On the fully battery car, there's no IC engine at all. There's a completely full batteries available. The battery is having external charge. So the battery is completely using to drive the vehicle. At the same time, along with a fully electric car, there is a further development is called fuel cell electric cars. Fuel cell in a fuel cell electric car is a chemical energy is converting into electrical energy. There is a hydrogen cylinder and the fuel cell component. So there is a transfer of hydrogen into the fuel cell, and then it is producing electrical energy, which is charging the battery. From the battery, then again into the energy is going to the motor. So this is additional new development. So all these changes are taking place on the electrical side. So all the while we were, all these above slides, we were talking about more towards battery and battery related and hardware related. Now we will be talking about software related. So this is where telematics and connected cars and telematics, all those things are related into software related. Like you can see, continuous car with a cloud connection and access to the data and integrated the chip inside the car, digital cockpit, automotive operating system, always the OTA. OTA is over the air assessment and other things and all is taking place. On the telematics is an automobile communication system. Okay, so information from the vehicle at the same time from the wireless network talk each other. So information will flow from the vehicle to the wireless network and the network to the vehicle. So this is the telematics. So on the telematics, what are the things are happening? We are collecting the data. There are so many sensor and other components are on the car. So each one has got some kind of a performing function. While performing function, how it is performing, all this information, we are collecting the data and analyzing the data. And aftermarket integration. Aftermarket integration is through telematics is like today, it is giving advanced information in how many kilometers is service interval, when you need to go to the service station, what is the life of the brake pad and other items we need to change. All these informations are coming to the driver and customer. So this is all with the help of telematics technology. Then external communication, like insurance company and all, they are extensively using telematics to manage the car data, like how the driver is operating the car, how the performance of the driver, and where the cars are operating. The cars are operating in the dense area or accident-prone area and all. All this information are useful for the insurance company to fix the premium. So, like a developed country and all, so they are changing the premium of the car according to the situation where the cars are operated. Even some places where when you are operating in the peak hours, the premium is more and all. So how they are able to have a differential premium is based on all this information. So the telematics are very useful to collect all this data. Limited onboard connectivity. So all this information are coming into the onboard, and we are getting some displayed messages in the connectivity. Third-party integration, again, like I was mentioning, any new software like insurance company software and all, there is a possibility of integrating with the telematics then for various purposes. So these all the advantages in the telematics system. Okay. Telematics and connected cars are separate. Both are separate, but they are complementary technologies to support the smart driving. So all are based on the software, but telematics has got some kind of a data collection, like a vehicle data and drive data. So both are complementary, but work differently. The telematics is collecting all the data, but connected car is leveraging the data, enabling advanced communication between the cars and the surrounding environment. So you see the difference. Telematics is mainly collecting all the information, and connected cars, because of the connectivity and other thing, leveraging the system and communicating our surroundings the car and effectively functioning the cars, the safety and other related area. Now we can see about the connectivity. Types of cars are connected. There are two types, basically. There are three types, but I'm mainly touching on the two types, embedded and tethered. Embedded is both connectivity and intelligence are built in the car. In the new cars, okay, all these informations are inbuilt by the manufacturer. Both connectivity and intelligence are inbuilt in the car. But in tethered, intelligence remain inbuilt in the car, but connectivity is external, external modem, either external modem or connected with a consumer's SIM card or something. So this is the intelligence is inbuilt in the car, but the connectivity is external. So this is where the difference between embedded and tethered. What type of connectivities or communication is taking place? There are few things, vehicle to vehicle. So because of the connected cars, we can able to monitor what are the surrounding cars and other information through cloud and all. So vehicle to vehicle. Vehicle to infrastructure. What is vehicle to infrastructure? When you are driving the car, if there is a infrastructure or road repair work or IC road, all this information, you can get advanced information, and based on the information, you can reduce the speed or you can take alternate route. All this kind of possible in the vehicle to infrastructure. Vehicle to pedestrian. So sometimes when there is a dead end or a blind end and all, we cannot able to see a pedestrian and all. So when the technology is available and it is getting information to the driver, so that we have to be careful. Particularly in developed countries where the cycling, pedestrians, cyclists, all these people are coming in the road. So this technology is very useful to protect these people. Vehicle to cloud. So directly all these informations are connected to the cloud, and the cloud is monitoring and it is giving information back to the driver, whereas there's a particular area is very traffic is very high and accident. All this information we can get back from the cloud. So then it is having a better driving experiences to us. Vehicle to grid. So with a fully battery car and all, so this system is connected to the vehicle to grid, where the infrastructure of charging and other, what is the battery condition, all this information is monitored, like how long we can able to drive the car, what distance the charging stations are available, all this information. So with this, in nutshell, vehicle everything. So in the connected car, the vehicle is connected to all these places, so that we need not worry about information is automatically coming back to us. Benefit of the connected cars. It's basically is a mobility management. See, complete now. We can able to manage our mobility, vehicle management, safety related. If any breakdown, how we can able to communicate to the call center, and we can get some assistance and the driver assistance information about well-being of the driver and the entertainment systems. All these informations are through connected cars. So with this kind of technology, both telematics and connected cars is more worse with the software dominated. And these two tours is taking to the next stage is, sorry, before that, there is the challenges. The challenges is hybrid. So what are the challenges in both the telematics and the connectivity? Today, the data privacy and the regulatory compliance, many countries has got their own country law, and you need to have some kind of a compliance procedures and all. So all these things we need to take care when we are forming a connectivity and telematics. So infrastructure development, again, we need a lot of infrastructure. These are the challenges we face between both together and telematics and connectivity. With this together, when is driving to software-defined vehicle. So today's technology, the car is like, when the mobile phone started, Nokia and all, the hardware is, the software is a little bit part, maybe a small part in the hardware. But today the technology is completely changed in the smartphone. Smartphone is completely software dominated. Hardware is okay, any phone you can buy, iPhone or any other phone, but the phone operation is same, but the software which is inside operating the phone is totally different. So the software defined in the automotive software defined vehicle, software SDV is a technological key, okay, to use entire life cycle of the car. Here, in the software driven, you keep on updating the software. You can continue to use the car, whatever the life cycle it is possible. Enhance the navigation connectivity. So software is very useful to enhance the navigation and connectivity. And you can able to upgrade all the applications in real time. Like iPhone, any changes are taking place, you can able to get upgrade immediately in the real time. The car is also, whatever the changes are taking place in the operating system, the manufacturer can able to push it to the car, and we can able to upgrade the software update within no time. This is where over the air, okay, the software update is remotely, immediately it is possible. Whenever the manufacturer is pushing the software, you can able to update it over the air system. The next is SDV. The infrastructure is, SDV is flexible and scalable. So once the hardware is fixed and we have taken hardware from the manufacturer and all, the software is very flexible. So you keep on adding or scalable architecture. Any changes are taking place in software, you can able to upgrade and you can able to improve your value of the car. At the same time, because of all this software, any defect on the car, you can able to get information on the dashboard, and information is coming to your dashboard. Then a lot of personalization is possible. Today, technology, and particularly now it started coming in, I saw in BMW and in Mercedes-Benz and all this infrastructure, like a heating system, seat heating system, cold countries, you see, the condition of outside temperature is very low. You need some kind of a heating system inside the car, maybe a heating system in the steering wheel, or heating system in the rear view mirror, or heating system in the seat and all. So all these functions are available. So in order for a customer to use these facilities and all, so they need to subscribe through software from the manufacturer. They need to pay additional money. I want to use it for this winter, these features. So they need to pay additional money to use these facilities and all. This is already started happening in many of the manufacturers today. So all these things are possible because of the software development. The benefits like what I was mentioning is access to the new features in the real time. All the new features is possible to access into the real time, and safety. With all the information, it is safe to drive the car without any much of a problem. Okay, and improvement in the value of the car. So with all the continuously upgrading the car, so the value of the car is improving. How SDV, software-defined vehicle, works? So in a car, okay, there is a big central computer is available. This computer is able to manage powerful data and robust and flexible. So all the data collected by all the sensors and driving assistance, management, chassis management, multimedia, all this data is fed into the centralized computer. The computer is processing the data with the help of the software and giving all this information to the driver or to the external agencies. Now we'll talk about autonomous vehicle. What is autonomous vehicle? Autonomous vehicle is working in the following principle. It rely on sensors, actuators, complex algorithms, machine learning, and powerful processors. So these are the items where sensor, actuators, all these things are working and executing this software. When all these components are working and executing the software, the autonomous car create and maintain a map of the surroundings. When all the information is coming to the car can able to manage what is happening around the car. So that's where the mapping is taking place. This is where I was mentioning all this information, how this information is coming to the computer, like radar sensor. Radar sensor is monitoring or positioning the cars or monitoring the cars nearby. Any cars nearby is monitored by sensor, radar sensor. Radar sensor is giving information to the main control unit. So many cars are nearby, you have to be careful and all. Same way, video cameras. Okay, nowadays the cars are having so many cameras. These cameras are detecting the traffic light, road signs, and track the vehicle. Any vehicle is tracking and also tracking the pedestrians. So this cameras is very useful to track all this information. Once information is detected, it is given into the control unit or computer. And lidar sensor. What is lidar sensor? Light detection and ranging. So this is sending a light signal and measuring the distance. So what is happening? Again, detect the edges and detect the lane marking. All this information is what is happening in surround. Apart from the radar sensor and vehicle video camera, lidar sensor is also monitoring the surroundings, giving the input to the computer. Then the last is ultrasonic sensor. When we are parking the car, sometimes there is a curb is available and all. So we don't know. Sometimes we may get the car get damaged, the bumper get damaged and all. So the ultrasonic sensor are very useful to monitor all this information and giving input to the computer, which again computer is processing and giving information to the driver. Be careful, there is a curb near the car and all. So this is where the autonomous car is taking all the input and processing into the computer through the software and giving information to the driver. Based on the Society of Automotive Engineers, there are 6 levels in autonomous driving. So it's again, you can see 0 to 5. 0 is a no automation and 5 is a full automation. So there are 6 levels in autonomous driving. In self-driving car, the car can drive itself in some or even all situations. In self-driving car, the car can drive itself in all places, on all situation, or in some situation. But human passenger must present. The human being should be inside the car and to be present and ready to take control. In case of any problem, then the human being should take control of the car. This is in the self-driving car. So the self-driving car, it comes into the level 3 and level 4. Level 3 is conditional automation and level 4 is a high automation. So self-driving car is coming into 3 and 4. in the fully autonomous car, it is coming on the level 5. In fully autonomous car, performance all the driving tasks under all condition. So it is performing all the driving condition with zero human intention. There may be no human inside, or there's no human interaction is required to drive the car. This is called a fully autonomous car. So currently, even developed country is not fully ready for fully autonomous car. But at the same time, there are a lot of work has done, like telematics, connected cars and all, to drive towards fully autonomous car. Just I'll give you an example. 5 years or maybe 7 years before, when I was there in Germany, I used to go to Germany every year to drive whatever the developments are taking place in the car. So I used to go there as a dealer. We used to drive the car and see the performance of the car. Almost 7 years before, when I was there, Germany, to test drive some new cars. So that was a time that automatic brake was incorporated in the car. So the trainer asked me to drive the car, and then even if there is a pedestrian or anybody is available or car in front of you, he told me not to apply brake. But normally we drive the car so many years, and psychologically, when somebody is coming in front, the pedestrian or car, we are bound to apply the brake. But the trainer was holding the car. So definitely the car was, the camera was there in the car. The car is sensing and applying the brake automatically. It was something new to me. I cannot able to believe. So this has happened almost 7-8 years before. So all these changes are taking place towards autonomous driving. So which is happening now, but it's still it will take another, I don't know how many years, but eventually it is going to happen, fully autonomous car. And now we have to really see the insurance policy and the regulations of the country. All those things they are mapping it. So this is where the technology is changing towards fully autonomous car. With all these things, both hardware and software, what are the impact is taking place in the after sales as well as the sales side? So on the after sales side, I'm touching on the dealer side. So dealer side, like what I was mentioning, the car is completely transforming into a new technology, high-tech car. All the while, the dealers are ready to use the infrastructure to manage or maintain the cars with IC engine, mechanical car and all. But with the new technology car, are they really ready to the infrastructure is ready to manage or maintain these cars? This is a big question mark. This is where the dealer really, in order to be there for in future, they need to invest now. But there is again chicken and egg situation. If still the technology is fully not arrived, country like India and all, but it is going to come. Now, whether to invest now or invest later. If you invest later, you may miss the boat. We don't know. So these are the few questions we need to continuously monitor and take a right decision on the right time. The second is a technical, like I was touching in the beginning, human resources, where the human resources all the while, they are tuned towards maintaining the mechanical car, IC engine car. But when it comes to the new technology like software and all, how much the older generation can able to manage the new technology car to maintain it. This is where some of the staff we can able to train. Some of the staff of older generation car we may not able to train. So we need to have some kind of a plan of those staff. At the same time, in order to be very up to date, we need to have some kind of we need to intake a new generation of staff into the system so that our workshop is up to date to manage both infrastructure and with the human side to manage all the new technology cars. Let us see, that is the infrastructure and investment side. What is the financial impact, both manufacturer as well as dealer side? So I split into two parts, sales side and after sales side. So on the sales side, I'm just touching the present and the future. Present in the sense, I'm giving a scenario about in India. Most of the auto manufacturers are operating the present system. At the same time, in India, manufacturers like Mercedes-Benz and all, they move to the new system, which is a future system. So, what is the difference between the present system and the future system? In the present system, manufacturer like Tata or maybe a Maruti or Suzuki, so they manufacture the car, then they transport the cars to the respective their own dealership. So when they are moving the car, they are invoicing the car to the dealer and they are invoicing it and collecting the payment of the cars for the cars they are delivering back manufacturer. So the moment the car is delivered to the dealer, then it is a property of the dealer and sitting in the dealers as the working capital and sitting as the stock. The moment any customer is interested to buy any car, Tata car or Suzuki car, they will approach the dealer and they will finalize the car, which car they wanted to buy. The moment they have finalized the car and they will pay the payment and the dealer will invoice the car in the name of the customer and deliver the car to after PDA and other things, they deliver the car to the customer. So this is a current process. But in the new process, is a completely different. What is the different is the dealer is become a sales agent. In the new process, the manufacturer manufacturing the car, they will keep all the stock in their premises. The inventory is with the manufacturer. Whenever the customer wanted to buy a car, like example, Mercedes-Benz, if any customer wanted to buy a Mercedes-Benz car in India, either they can go to the website of Mercedes-Benz to check the spec and other details. At the same time, they can also go to the nearest sales agent and they can check with the technical data. The customer can go to the dealer, they can check technical data and they can do the test drive, etc., etc. So based on this information, they can finalize the car, which model they wanted to buy. Once they have decided to buy, example, maybe a C-class they wanted to buy, the moment he has decided to buy, he will place order directly. This is all online. They can place order directly with the manufacturer. The moment they place order with the manufacturer and the manufacturer is based on the availability of the car, he will inform the customer what is the tentative delivery time, all this information. So then there is a financial taking place. So dealer has to make the payment to the manufacturer. So once the payment is done and agreed the terms and the delivery time and all, the manufacturer will invoice directly on the customer. The copy of the invoice and the car will go to the nearest sales agent where the customer wanted to take delivery of the car. So the flow is taking place. The copy of the invoice and the car is going to the sales agent. And original invoice go directly from the manufacturer to the customer. So the moment sales agent receive the car and say a copy of the invoice, they will contact the customer stating that, hey, this is your order and the car has arrived. So then they will prepare the car, all the preparation of delivery and other things. So they will deliver the car back to the customer from the sales agent premises. So this is a basic difference. Because of these basic differences, what is the impact? Impact is the margin is reduced considerably, almost normal circumstances, maybe around 7 to 8%. So when the future system, almost there is a reduction of 5% in the sales margin. This is a huge impact is taking place. Already worldwide, Mercedes-Benz, BMW, Stellantis, all the manufacturers, they are moving to the new format. But in India, only Mercedes-Benz is moved to the new format. But rest of the manufacturers, they are looking into moving to the new format. Why they are looking to the new format? Because lot of investment is taking place in the manufacturer side on the R&D. So this is where in the past, in the mechanical car, there is an investment in the R&D, but when it is taking place in the software, there's a continuous update is taking place. There is a continuous investment in the R&D. This is where we need to really huge investment manufacturers are making. So there they are trying to look other areas where they can able to maintain the profitability, cutting down the cost. There are three areas they are looking into it. Consolidating the dealer. Today there is a big dealer, small dealer and all. So they are trying to manufacture, trying to consolidate the dealer. They don't want to have so many dealers and all. So they are trying to consolidate and trying to work with a minimum number of dealers. Then the agency model. This is what I explained, retail of the future or the agency model. So this is the change is taking place from the dealer to the sales agent. The third is direct sale. So like Tesla and all, there is no sales agent, there is no dealer and all. So they are directly making all the sales and taking care of the car and all. So this is the third model is the direct sale. So all these changes taking place in the retail network. That's the financial impact on the dealers and others. Okay. Then what is the impact on the after sales? Because of the car, less moving parts and the software driven, all these things are reducing the scope of the work and impact on the after sales revenue. The revenue side, service and maintenance, almost there is no parts, there is no maintenance on the car. Where is the maintenance? Only battery. When there is a battery failure, you have to throw the battery and fix a new battery. So there is no service maintenance. Almost revenue from the today, you need to change so many items regularly. You have to visit the workshop. So that revenue impact on the service and maintenance is almost around 85%. And the parts replacement, the parts is reduced from mechanical to EV considerably. So that's where the reduction in the parts. Repair scope also reduced. Accident is reduced to 50%. People can ask question, car is a car, whether battery car or IC engine car, still bound to have accident at all. But why there is a reduction in the accident scope of repair? The accident scope of repair is reduction is because the new cars are become very, very intelligent. So those days, if there is anybody is coming, then if there is accident and all is taking place. Today, the cars are intelligent. It is trying to apply the brake and there is a 360 camera sensor available and less accident possibilities and all. So that's where the scope of the repair, accident repair is less and accessories less and the sales, which I have touched it. So this is the scope of the sales and after sales area impact. With this kind of impact, how the dealer is going to sustain or survive, that's a big question mark. Okay, so now almost I'm come to end of this slide presentation. So what is the takeaway from this presentation? Okay, a lot of things are happening in the auto sector. Okay, that's everyone is aware. And in order to be associate ourselves very closely and continuously, we have to be very active and update ourselves very closely and continuously. And for non-automotive members in this group, it's a good update. I believe it is a good update about auto sector. For automotive members, those who are already associated with automotive sector, many of them aware of the developments. This is only an eye-opener. And however, this presentation will help enrich and refresh their industry knowledge. For automotive retail entrepreneurs, the financial impact is really is information, and you have to be careful how the future is, how we need to make investment and other things, investment plan and all. So these are the few takeaway from this presentation. I think I covered almost all these points, whatever I wanted to communicate. And thank you very much. And thank you very much for your attention.
Thank you, Mr. Devaraj. Thank you very much for your time, Mr. Devaraj.
Thank you, Gopi. Thank you very much for your opportunity.
Can we keep the floor open for the question and answer session, please?
Yes, yes.
Yeah. Participants, you may please unmute and ask your questions, please.
Yeah, thank you, Mr. Devaraj. It was a very nice presentation. And I have one question. See,
Yes.
nowadays I'm seeing during this transition period, I'm seeing a lot of new models coming, new models, various things. I don't know whether this will, how they are able to, will be able to sustain. Can you please enumerate, sir?
It's a very good question. I couldn't understand, get your name, but I will answer your question. See, a lot of the transition is very, very important time. Like most of the manufacturer trying to bring the car with the changes, either hybrid or EV cars, but still IC engine is continuing. But my experience is it will take some time. In a place like India, it will take some time to IC engine completely eliminate. I'm giving IC engine to completely eliminate. So there is a transition. So see, normally the life cycle in the passenger car is something around 5 to 10 years. In India context, I'm telling. After 5 years, 6 years, people will tend to change the car. So this transition period, still we can buy a IC engine car, but you need to see what is your lifespan, your expectation and all. But at the same time, when I'm touching this point, but I want to touch one more point. Ultimately, EV is not the ultimate. Okay, because EV is again, I from my experience, I would say is a transition. Why I say it's a transition? Okay, we are replacing the fossil fuel car, which is creating pollution and all. But at the same time, battery energy, in order to produce a battery and battery disposing the battery is also another big task. So in order to produce a battery, also you need to have a lot of other related pollution is taking place. Eventually, I believe the hydrogen is the ultimate where there's no pollution at all. Hydrogen is available freely without polluting anything. So that is a clean energy. So, but we are in the transition, but we need to be careful what we wanted to make investment to buy the car. Am I addressing your question?
Yeah, thank you so much. But I mean, what I am afraid is, see, new models are so many models are coming. I'm afraid daily I'm seeing a lot of advertisements, competitions, and once the EV, it is totally EV. Whether the what will happen to the thing? I mean, existing models,
No, this
will
is
they suffer a
where
loss?
so this is where now again government has to take a very very supportive role. See today the cost of EV car is very high. Okay, but slowly it's reducing because of the battery protection cost and all. So once today IC engine price compared to EV car is less, but over a period, because of the maintenance and other things, EV car maintenance is cheaper and overall it will work out cheaper. But now government has to give a lot of support. This is where recently I was reading an article. Tata and Eicher has got some kind of a support, some government subsidiary on the EV car and all. So with this, with the new model, we again, with the technological change, we need to be a bit careful, and infrastructure is not also not fully ready. So we should not get into, because once you buy this car, particularly EV car, you don't have a proper infrastructure for charging these cars. Then you will become a phobia on charging. How not to charge my car? You are driving 300 kilometers, like you are driving from Chennai to Trichy. Whether you can able to drive without any charge in between. Okay, once you reach Trichy, whether you have a facilities, you have a car, or you are staying in a hotel, and you can able to get a charging and all. These are the questions. These are the questions we need to get answer, which I don't have any answer, but time only will tell.
Sorry, sir. Thank you very much. And one more last question.
Yes.
Can we ask a question, please? Give other people an opportunity.
Yeah, good afternoon, Devaraju sir. Sachidanandan here.
Yes, Mr. Sanchidanandan.
Yeah,
Yeah,
you have talked about that dealership infrastructure improvement and lot of investment is required for the workshop and other activities. So, but
Correct.
the revenue side it is dropping down.
Correct.
So how will it be viability and profitability for the dealers and retail network?
Okay. See, what is happening is there is one information which I did not share. In future, maybe once the car become fully autonomous and soft-driven vehicle, the scope of making a revenue from auto dealers are getting reduced heavily. This is where the generation or revenue generation is selling a software from the dealership. Example, like if a car has got all the facilities, just I was mentioning in my presentation, like BMW or Mercedes-Benz, all the facilities they built in the car. So when they built in the car, when I am a customer, I am buying the car. So my car has got a lot of facilities, but I may not be able to use the facilities. I need to subscribe what are the facilities I wanted. So in order to subscribe, I need to make a payment to the dealer and eventually to the dealer, eventually to the manufacturer. So these are the revenue generation. So when I make some portion will go to the dealer, some portion will go to the manufacturer because the part sales is less and the repair scope is less. So there is no revenue at all. So these are the software selling is taking place. So this is another revenue generation. This is what they are indicating. But again, how much is the revenue drop? Other is going to really complement or supplement the software selling into the current revenue of selling spare parts and service scope.
Mr. Devaraju, can I ask a question, please?
Yes, please.
Yeah, my name is Satyanarayan. I'm logged in from Arizona and USA. I listened to your presentation. Very, very impressive. Thank you. And I'm an MIT graduate as well from the 2026 batch electronics. Okay.
Thank you, Satyanarayan.
I have a couple of questions. Number one, as you well know, China with BYD and many other companies are extremely competitive in the EV world. My area of interest is in the EV segment you just talked about. I was also in India last year. My brother drives the Nexon, which is the Tata car. But I don't see any aggressive moves by the Indian automotive people to sell cars in America. But we already have so many of these Chinese cars, EV cars in the United States, especially where I live in Arizona. We have Lee Automotive, Lucid. We have BYD, which is very aggressive. And as you very well know, Tesla is also aggressively cutting prices, okay? Prices are coming down. So what is the competitive spirit in India in terms of exporting cars, electric cars, EV vehicles into United States and the rest of the world? That's my first question.
Okay. Thanks, Satya. I'm really happy that there is an MIT member in the group. Okay. Coming back to your question, see, China is very, very aggressive in the automotive policy. And
yes.
And they are already they are producing so many cars. I was there almost a few years before when we were entering an agreement with one of the Chinese manufacturer for importing the car to Malaysia. So these Chinese, their mentality is totally different on the business. So they are trying to go anywhere in to do business. So that's a basic principle with them. And also, why they are promoting more on the hybrid, EV cars. There is in the lithium, in order to produce lithium ion battery and all, I understand a lot of raw materials are available in China. They are trying to explore all this raw material availability, and I think government is giving a lot of support to the manufacturer so that they can produce and they can able to export the cars with the government support. But in India, still, we are in a very, very early stage. We are not really as aggressive as Chinese manufacturer.
Yes. Mm-hmm.
So this is where the government has to play an active role. This is where the FADA, Federation of Automotive Dealers Association, and the Automotive Manufacturer Association, they are working very closely with the government, how they can able to get support. In fact, there were support for the two-wheeler like Hero Electric and other. They were getting support due to whatever reason, because I don't know whether somebody says it was misused or something, then the support was reduced. But still, recently I read the government is extending additional support to Tata and Eicher Motors. All these people, they are getting. So without government support, it's very difficult to compete in the international business. So that is a major role the government has to play.
You're right.
Fortunately, Nitin Gadkari is playing a major role, but still, that is not sufficient to go into the overseas market. Overseas market is very, very, very competitive. If you are not able to manage your production costs as well as the technological advancement, you will be nowhere in the international market. So this again, domestically, again, one more point. Recently, I came to know a lot of the mines and all, the Kashmir and other area, they are identified where they got lithium based raw materials are available and all. Once you have this kind of raw materials, and our production costs also will low. So this is a good possibility. Once we have this infrastructure and raw material, and maybe with the government support, we can able to be a competitive in the international market. It's a matter of time, so Mr. Satyanarayan.
Thank you very much. Another question I had is, you mentioned about traveling from Chennai to Trichy, Tiruchirappalli. How about the EV infrastructure in terms of charging stations? Do we have a good infrastructure in India in terms of customers able to easily charge without getting stuck in some place in the middle of the road?
Okay, it is not really, the infrastructure is not very good, to be very frank. Okay, today is inside the city, there are charging stations like Ola and others charging two-wheeler and all. We can charge four-wheeler also. But again, majority of the charging stations are in slow speed charge. Okay, so you need to wait for 5 hours, 3 hours, 4 hours and all. So you see, when you drive from Trichy to Chennai to Trichy or Madurai and all, 300 to 500 kilometers, if you need a fuel stand, you can go to within 5 minutes, you can fill up the fuel and you can keep driving. But in the charging station, in the infrastructure is very, very early stage. So this is where you need to have a battery capacity where the long travel is possible. Like maybe one full charge, maybe you can drive at least 300 kilometers so that you can reach Trichy, and there you can see some. Because once you reach next station or city, then infrastructure is slightly better, or maybe you can use other infrastructure. But on the highway, still infrastructure is very much lagging, and a lot of infrastructure is requirement. We need infrastructure requirements. What is happening is government is working, or private companies are working, like Tata Power is working with various agencies along with the Tata Chemicals. They are trying to work with the battery production as well as charging station. And Amar Raja battery is coming with the swapping of batteries. So these are the manufacturers, Amar Raja battery, Tata, and I heard other few companies also trying to work with various people and trying to provide. See, when I was in Malaysia and all, so we were started discussing with some of the agencies like Petronas and Shell and all. They won't have every fuel station, there is a charging station available. So government was very supportive to come out with some kind of financial support. So if we can get this kind of a government support in India, so you can able to do all the petrol station like BP or IOC, all the station, you need to have a charging station, particularly fast charging, rapid charging station.
Right, you need the fast charging, exactly. That's wonderful. The other question I had very briefly, I know there are other people might be waiting to ask you questions. In the United States, when we buy an EV car, we get an incentive of $7,500. Does the government of India have any such plans for customers in terms of incentives?
Not really. They are not giving directly to the customer, but they are giving some subsidy to the manufacturer so that they will reduce the car price. But I agree. Even in Malaysia, when I was there, so if you buy a car, EV car, so you can give all the registration detail and all. You can get direct financial support, but not in India.
Yeah, I think it'll be forward-looking for the Indian government and also state government or Indian government to give, because it's the customer who pays for the car, right? I mean,
Yes.
Yeah, dealer gets the advantage, but the dealers don't pass all the cost savings to the customer. The customer needs to have the direct savings. In the United States, I can tax write off $7,500 when I file my taxes. So those are the kind of investments or incentives the government should give to promote EV and reduce the carbon footprint in India. That'll be good. That ends my question. And lastly, I was very impressed. I'd like to have your email so I can be in touch with you. Will that be in the presentation, please?
Unfortunately, I did not put. Maybe I will ask Kopi to communicate, or how to communicate my phone number and.
Yeah, your mobile number and email will be good. So that'll be excellent. Okay, thank you so much. Okay.
Thank you, Satya. Thanks for your questions.
Okay.
Gopi, can I go ahead and ask? Gopi, can I ask a question? Hello.
You may proceed with your questions, please.
Yeah. Hi. It was very nice presentation. I'm Vishwanath, 82 Chemical Engineering, Annamalai University. Two questions I have. First, there are so many choices of fuel. CNG, petrol, of course, diesel, not in cars. Then you have now hydrogen, EV. It's a real confusion because there are exclusive technologies and you cannot substitute one with the other, number one. EV doesn't make sense at all. The cost of money in India is about 10%, unlike the West, US or Europe. So it doesn't make sense. The additional cost of EV, unless you drive 500 kilometers every day, maybe it will work on a taxi. But for an individual to use a EV, it doesn't make economical sense at all. Forget the infrastructure. I'm talking, just rupee and paise. If you calculate depreciation and interest, it just doesn't work. Even if you give a 10-year life for the battery, it doesn't work. So I do not see, EV making a big in India because the cost of money. This is the second thing. The third is, once the whole thing is autonomous, why would people want to own a car? What is the point of owning a car when the car drives by itself? I think the model will be like, you just press a button and the choice of car will come. If you want to go to a wedding, maybe a bigger car. Maybe you want to commute to work, a smaller car. Maybe to meet a friend, you may have even, the smallest of the lot. Just my thought. Can you answer all these questions? Thanks.
Yeah. Okay. The first, the point, value and operating cost of the car. Okay. Today, the EV car price is very, very high. Okay, one is if there is the considerable reduction is not taking place on the EV. So again, your question is unanswered because of the fuel average and operating distance and all. So once you reduce the value of the car, the price of the car, considerable level, and then your investment is on the car is less, that will proportionately reduce your operating cost. So currently now we are not getting enough support from the government. So that's where the price of the EV car is very, very high. Added to that, infrastructure. Okay, since you have not touched the infrastructure, I will take out to the infrastructure. So this is the price of the car is a very important component to reduce your operating expenditure. Second, you asked is autonomous. See, I fully agree. Once autonomous car is there, so So you can call the car and you can sit in the car, and you can use individually, or you can use a combined car or anything. So yes, but but place like India and all, it will take really some time to get it. Even in US and other countries, really it will take some time to get an autonomous car, and eventually it is going to take place. But yes, once if the car is available, you don't need to own a car. Am I able to address your question?
Yeah, hydrogen. The problem in hydrogen, I think, is storage.
Yes.
Our senior 1967 batch, Mr. Sitaraman, went to Europe to get the technology for 500 bar pressure vessels to store hydrogen. The project cost is also about 26 million euro. But the problem in India is still we do not have a standard for the type 4 hydrogen gas cylinders. Fully composite cylinders, the approval, the ISI doesn't even have a standard. Now they have approved type 3, where there is a metal liner and a composite overwrap. But you need really for hydrogen to penetrate, you need a type 4 cylinder. And again, 500 bar pressure vessel in a car is really a bomb. So Mr. Sitaraman of Super Auto Forge, it's a big company, our illustrious senior. They backed down, and now they have invested the money in defense program. So storage of hydrogen is in a vehicle is going to be very, very expensive, and infrastructure even worse, because hydrogen embrittlement will take place. So it's not easy. Probably CNG with some 20% hydrogen may be the low-hanging fruit. Probably people will go for that immediately, because CNG infrastructure is much better in India. Thank you.
I fully agree. The big question is on the hydrogen fuel, is really the storage tank. But we have to see how the technology is going to change. Eventually, we need this kind of technology, because EVs, again, I will say it is only a transition, because production of a battery and other things and disposal of batteries, another big task. So, but the time being, compared to fossil fuel, maybe EV is okay, but eventually we need to have hydrogen. But hydrogen is a big task, is the storage capacity. I'm not an expert in hydrogen side, but definitely I fully agree with you. The storage is the main concern, and we need to have a solution for that.
Yeah, Nagasubu, please go on.
Hello, good afternoon.
Good afternoon.
Naga, I'm head of after sales for Mercedes-Benz Group, Mercedes-Benz dealer group in Malaysia. First of all, thanks to Annamalai Alumni Business Network for arranging this wonderful session. And secondly, thank you, Mr. Deva. We miss you, Mr. Deva, and Malaysia, and your leadership. We are missing you. And my questions, I have two questions. Refer to the EV changes in the current market. Any changes to be done in after-sales customer service in the sense of customer satisfaction? And my question number two is, how to increase revenue per car when without engine the car is in electrification? What are the efforts, what are the initiatives we need to take to increase the revenue per car?
Thanks, Naga. Thank you very much. I also miss really Malaysia. Okay, coming back to your point on the customer satisfaction. Customer satisfaction, whether EV car or IC engine car. So customer is a touch point. Wherever customer is touching the business touch point, we need to be very careful how we can able to consistently deliver our performance on all these touch points. So I don't see any big difference between the IC engine and the EV car. So any customer, any transaction, any touch point, how do you want to handle the customer so that the customer is fully satisfied? Okay, so the touch point is very, very important. It can be a IC engine or it can be an EV car. Regarding the revenue per car, okay, now the scope is like what I mentioned in the presentation, the scope is reducing, and particularly in the fully EV car. Hybrid car, still there is a scope, but on the fully EV car, there is a big reduction in the scope of repair and spare parts replacement. This is where we need to work closely with the manufacturer. We need to take up with the manufacturer. There is a scope of repair, work reduction and all. What are the other revenue possibilities? The manufacturer need to share, other revenue opportunities, and maybe they need to increase their support on the financial and all. Otherwise, dealer with a high cost of infrastructure, and the dealer has got a big investment is land and building and the salary. These two are the important factor. So the land and building is still you need, and we need a people. So you cannot able to reduce these two big costs. So when you have a big two cost, when there is a reduction in the revenue, definitely we need to work closely with the dealer, how we can able to compensate the reduction loss of revenue.
Yeah, okay, sir. Yeah, noted.
Thanks, Naga.
Hi, Devaraju sir, this is Venkatesh.
Yes, Venkatesh.
Thanks for the wonderful presentation and sharing your 25 years of experience in this field. I have just one question. What do you think, like in a countries like India, we should like focus more on developing infrastructure for personalized vehicles or public transportation?
Again, the personal there's a disturbance. Okay, so what is the public transportation is economical as of now, and it's also the cost is increasing. So, but the safety and other parameters, particularly after COVID, so people. Before COVID, people were very confident on using public transport system and other thing. After COVID, they are very cautious on the public transport system. But again, operating economy and government infrastructure on the road and the infrastructure of a public transport system, whether it's a private or public transport system, if the infrastructure is good and in order to be economical, we can use a public transport system. Particularly in India, if you compare to North, South India, still you can see there's a good buses are available and the public transport system is better. But still, we are not fully there in the public transport system. We need to have our own transportation, dependency on our own transportation. So once if the full public infrastructure is there, but again, I put the blame on the government. Today, our public transport system is not up to the mark.
Thank you, sir.
Okay.
Good afternoon, Mr. Devaraju.
Good afternoon.
May I ask a question?
Yes.
Hello. Let me introduce myself. My name is Arul. I'm head of after sales for Kia distributor in Malaysia. Firstly, I would like to thank and congratulate you for a wonderful presentation. I enjoyed the sequence of your slides where you brought through the entire audience in a very methodical manner to have a very clear understanding. And yes. And in fact, I agree with you in 2 points. One is that I too believe that EV is only a transition, and eventually it will be hydrogen that takes over the market. But this is only my feedback. My question is, can you share to the audience what kind of activities are you involved currently in your automotive consultancy? Thank you, Mr. Devaraju.
Thanks, Arul. Thank you very much. And basically what I'm doing is I'm working with auto retail business, both in overseas like Malaysia and some of the dealership in India. So where because the manufacturer, they got a lot of resources and all their facilities, they can able to work and they able to manage all these developments. But particularly on the dealership, they are not fully infrastructure as well as knowledge-wise and all. This where I started working with the dealerships and doing some consultation, study the dealership, what is the revenue stream is coming, current business is whether they are able to tap the full potential of the business. Okay, what are the area like sales area? Is there full potential? They are able to tap all the full potential. Similarly, in after sales. Okay, so first point is whether they are able to maximize the potential of the business. Number one. Number two, during the transition, what type of planning on the investment and the infrastructure development they need to do. So this will take the transition is maybe 5 to 10 years and all. So in order to take 5 years, it's just I will give my input of planning and other things. So this is where we will have a transition period, but currently working with to tap full potential of the business and any other opportunity for the dealer to make a revenue.
Thank you for sharing, Mr. Devaraju. I think we should continue to have more sessions like this and discuss to enlighten ourselves on the future of electric vehicles globally. Thank you, sir.
Thanks, Arul.
Hello.
Hello.
Am I audible?
Yes.
Yeah, please go on. Please go on.
Okay. Sir, good afternoon, sir. Muthukumaran from Daimler. I think.
Oh, Muthukumaran. Okay, okay. I'm fine. How are you, Muthukumaran?
I'm also fine, sir. It's very nice to hear your presentation. In fact, I will introduce myself to the audience. I'm also MIT student of 44th batch. And in fact, I worked along with Mr. Devaraju in Malaysia from 2006 to 2011. So during that time, we were in one of the distributors. So thank you very much, first of all, for giving an overview about the automobile industry, starting from the conventional stage and how we are evolving into the new technology. Of course, I am also equally echoing your view. Whatever the transition which is happening, and some of our colleagues have expressed this is not viable at the moment, which is true also. But once the transition is over, somehow our government also will compel to move in adopting either fully EV or maybe EV plus hydrogen cell. We will be doing it. Maybe I'm seeing in 10 to 15 years down the line. But one thing which I'm just sharing my thought, sir, one of the points which you have mentioned in your PPT is the technical skill, especially at the dealership or equally at the OEM also. While the new technology is coming, I think it's a time for our educational institution, maybe an engineering institute or maybe a polytechnic institute or even the ITA institute. We need to see that curriculum, whatever they are studying in relation to the automobile now, is it in tune with the future technology? If not, I think it's a time for us to change and then equip them to go more with the electronic-based learning on the automobile technology, which will definitely have a higher edge, especially for our Indian automobile market, which we can compete in the future also. So this is my view, which I thought of echoing it in the forum. Once again, sir, thank you very much for listening your presentation. I got this link through one of our WhatsApp MIT group. So I thought of it's an opportunity for me also to be in this seminar. Thank you once again, sir.
Thanks, Muthukumaran. So I take your valuable feedback. I fully agree on the human development on the change in the technology. So I fully agree. What is happening is already I am also working with some of the head of the department in automobile engineering, certain colleges like SRM and even sometimes I go to MIT and all. I try to associate myself where we can able to add certain value on the syllabus. Because the current syllabus, whatever the technology and the teaching session and all, we need to upgrade ourselves to the tune of the new technology, EV and fuel cell, all these changes. So I fully agree. We need to really work on the colleges and the universities to change the curriculum according to the need of the industry, so that once these students come out of the college, they can able to absorb immediately and with good institutions, good companies, they can able to be productive from day one.
Yeah, thank you, sir. Thank you very much.
Thank you.
Yeah, Sivaraman, please go on, Siva.
Yeah, good afternoon, sir.
Good afternoon,
thanks, sir. It was a very wonderful presentation. This is Shivaraman here, 98 E&I batch. I have a question, sir. Maybe I'm not sure whether somebody has asked this question in between. I got a call. Why this hybrid cars are not promoted in a greater way, and that too on the smaller versions particularly, and why it is also expensive, sir? Even if there are hybrid cars, it's on the expensive side. So I just want to get a limelight from you, sir.
Okay. On the hybrid car, again, you need to have so many components. You need to have an IC engine and you need to have a battery. So there are, it is not really hybrid. It's not going to be economical. Then you are having so many, you want to go with a fully electric, you need to have a full benefit of electric cars. Hybrid, again, you need to have IC engine, transmission, all those things. Then you also need to have a battery cost is there. So it's really, it's not economical. But the battery car is also expensive. This is where we need to have a support from the government to get the real price reduction on the EV cars. But still, technology is not there for fully for EV cars because of the infrastructure and other support from the government.
Thank you, sir. Thanks for your explanation.
Yeah, Nagasubo, please.
Good afternoon, sir. This is Govind from Pijot, sir.
Yeah, Govind.
Your presentation very good, sir. Excellent. Lot of information. EV car.
Thank you. Thank you, Govind.
But regarding the accident one, what are the precautions they need to take, the service center or the customer?
So once the accident baseness is definitely is going to be a big impact. See, but again, it may take some time. When the car is getting intelligent, like all the sensors are available and the cameras are available, so it is detecting and managing the safety point. Like even if the driver is driver has forgotten to apply the brake, the car is going to apply the brake on its own. So these are the, and when you are parking the car, those days there is no sensor and no camera. So you try to hit the bumper, front bumper, rear bumper, on the side damages and all. So with the 360-degree cameras and all this, the technological advancement in the car, so the possibilities are reduction in the accident, the scope of repair. So this is where the accident repair business is going down. So in future, once the business is going down, you need to reduce your investment on the body repair. Instead of big workshop, maybe you have to reduce a smaller workshop. So these are the changes you have to reduce your investment so that your return on investment, still you can able to maintain your automotive business. Accident business, sorry.
Thank you, sir. Thank you, sir.
Thank you.
Hello, sir. Good morning. This is Yashoda, and I got a link from Mr. Rasundar. Yeah. Okay. Thank you so much for the presentation. It was really informative. I have a question regarding that investment in stock markets. So, do you think that investing into battery, like have you mentioned just now that Amar Raja batteries and all? So, is it a viable business to invest into, or any kind of what kind of components we can invest if we are looking into through a stock market, not directly into dealership or anything?
Thanks, Yashoda. Thanks for your question. See, basically, the stock market investment, I fully agree. There is a lot of EV companies like Amar Raja Batteries and other companies also there, where the stock price is going to, even Tata Power and all, the future they are predicting very strong once they associate with infrastructure and other things. So the revenue stream for all these companies is going to increase. Like example, in Amar Raja battery, one is the battery, currently they are producing mainly lead acid battery and all, but they are also started working on the lithium-ion battery. Now, mainly they are focusing on the two-wheeler. And while working for the two-wheeler, they are also trying to work on the battery swappable. So what is battery swappable is, like in China, this concept is very, very common. So any two-wheeler, okay, if the battery is down, so they need not wait for charging and all. They can go to nearest, like Amaraja Battery Service Center or something. They can give this battery. They can get a fully charged battery. Immediately they can able to replace the battery. So this is another revenue stream for Amaraja Battery and Amaraja Battery dealers and all. So when I was reading Amaraja Battery, the business plan and all, so with this kind of revenue stream is coming, definitely the top number is going to come, going to increase, and the profitability is going to go up. Eventually, the share price is going to go up. Same goes to Tata Power and Tata Chemical. They are joining together. Tata Chemical is going to join in the battery production. At the same time, they are working with Tata Power to create an infrastructure in the charging infrastructure across the country. So with all this kind of additional revenues taking place, revenue stream is taking place in this company, definitely the top number is going to go up and the profitability is going to come. The share value is going to go up.
Yeah, okay. Thank you, sir.
Thank you, Sudha.
Hello, Mr. Gopi.
Yes, sir.
Sir, actually, one thing, coming to the one good way forward is we have got one alumni, Mr. Satya. You know him, I think. Ashok Leland.
Yeah.
He's a technical.
From the 90 batch, yeah.
Yeah, he's in the verge of, I think, retirement. I think good way forward also, like if we connect Mr. Devaraju with Satya, we can propose something to the government or some kind of thing, to take up further, like innovative ideas or something we can propose to government through Mr. Shivashankar, our transport minister.
Transport minister. Yeah, he's also the same batch as Satya.
Yeah. Mr. Devaraju and we can form a team and make a proposal that would be good. If viable and feasible, we can do something.
The first thing is we'll try to connect Devaraju with Satya, because Satya runs an academy, a design academy. So that
He's exotic. I mean, he's fantastic in terms of innovative stuff, and ideas are excellent with Satya.
Okay. Yeah, we'll do that.
Okay, thanks, Mr. Gopi.
Thank you. Anyone else has a question?
Hi, this is Rajendra Sapre. Good to ask. Yeah. So first of all, Mr. Devaraju, I thoroughly enjoyed this session because we are ourselves into this IoT and basically telematics development, 2G and 4G for automotives, mainly nowadays for EVs, two-wheelers. So this entire evolution, actually, I liked, how you have presented it. A little bit, only for a few minutes, I missed your session. But how do you see the digital twins or digital threads in the new technology perspective here for automotives?
Thanks. Some disturbance. Thanks, Rajendra, for your question. Digital is definitely is not going to be a threat. It is a supplementing to the technology. So without digital involvement we cannot able to do digital and the technology like telematics, IoT, all those things are going to work together and to really take the industry to the next level. So I don't see it's a threat. Digital is not a threat. This is my feeling.
No, I'm not saying threads. Digital twins is a concept under this industry 4.0, right? Modeling the vehicle, and being able to see the performance in real time.
Oh, okay. Sorry, I thought it's a thread.
No, thread.
Thread, okay. really some voices. See, you put it rightly, it's a thread. Now, when it is working together in digital and transformation in, it can be a connector or telematics and all. So the data and the digital, the data in the digital form is very, very important. So what is taking place in the connector car and or telematics? The controller or computer is collecting all the information, the data. So it is processing through software and communicating with the cloud and all. So then without this kind of the main line of data technology, so is difficult. I think it is working with the data technology is very, very important.
Yeah, thanks. Thank you so much. Yeah.
Thanks.
Sir, one question, sir, from me.
Yes. Yeah.
Thank you, sir, for a wonderful session, sir. I just want to ask you, since the hybrid, that is the fossil, I mean, the fuel plus battery will continue for a little longer time because of fully electric infrastructure issue, etc. So what is the actually growth if we compare the three, I mean, in the market, business growth, if we compare the normal car, the regular automotives, and the hybrid and the fully electric, is there any, sir, some percentage if you can give year on year, some idea?
I don't have right now the data, but every manufacturer is projecting there is a growth in the EV sector. It can be a hybrid or it can be a fully electric cars. Like you take particularly the manufacturer like Tata is very aggressive on the EV cars. Already started investing in the battery plant in overseas. They are taking a JLR support. So they are investing huge on the battery technology and all. So again, it is manufacturer to manufacturer. But still, a company like Toyota and all, they are not... they are looking more than EV. They are looking into fuel cell and hydrogen side and all. So this is, if you say ask the data, but everybody is projecting some kind of a growth in EV side. But again, it varies manufacturer to manufacturer. If you are Maruti is still, they are coming out with one or two models. But Tata is coming out more aggressively. So Hyundai and Kia is more aggressive because they are getting a technology from parent country, Korea. So wherever they have a technology, they are aggressive in promoting EV. Wherever the technology they are taking a bit slow manufacturer, then the growth volume on the EV side is less. So you cannot able to collectively compare, but is again a manufacturer to manufacturer, Sanjay.
Okay, sir. Thank you, sir.
Thank you.
Anyone else has a question? One last question. Okay. Thanks, Mr. Devaraj. Nice
Thank
session.
you. Thanks.